Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 25 to 29 of the Algebra 1 Common Core Regents exam for January 2015. All right, let's take a look at problem 25. It reads, Miss Fox asked her class, is the sum of 4.2 and root 2 rational or irrational? Patrick answered that the sum would be irrational. State whether Patrick is correct or incorrect. Justify your reasoning. All right, so first thing you want to notice that whenever you add or subtract two rational numbers, the result is always rational, okay? But in the case of irrational, as long as two numbers are different irrationals, you have two different rationals, if you subtract or add them, the result is always irrational, all right? So keep that in mind. Now, in order to solve this problem, first thing we'll do is we're going to classify these two numbers as rational or irrational, and then we're going to find the sum and see how we can classify the result. Is it rational or irrational? If the result is irrational, then our conclusion is that Patrick is correct. If the result is rational, then Patrick is wrong, okay? We want to make sure that we answer the question and provide justification for our reasoning, all right? Okay, so part one, let's start with the first step. First step is the classification of the numbers. So let's go ahead and classify. So the first number we have is 4.2. Now, what kind of number is this? Is this rational or irrational? 4.2 is rational. Why? 4.2 is rational because it is a terminating decimal, okay? This is a terminating decimal. Any decimal that's terminating or repeating is rational, okay? All right, now how about the square root of 2? What kind of number is this? Is this rational or irrational? This number is irrational. Okay, there are multiple reasons how we can determine why this is irrational. First of all, it's an irreducible radical. So if you have a radical that cannot be simplified into an integer, then it's irrational, okay? But let's say you have something like the square root of 4. This can be reduced into 2, right? And this is rational, but this can be simplified into anything else. So a number with a radical piece that cannot be simplified or eliminated is irrational, okay? This is one reason. Another reason that that we can use to justify why we selected this as being irrational, we can use our calculators here. Now, if I find the square root of 2, what do we notice happening? Square root of 2, enter. This is a non-repeating and non-terminating decimal, okay? If you enter it into the computer, this number goes on and on and on, okay? This calculator just cut it off at this number of decimal places, but this number is non-repeating and non-terminating, okay? So let me show you exactly how this should be written. This expression is actually is inaccurate. Let's change colors here. So the square root of 2 is approximately 1 point, let's see what the calculator says again. Square root of 2 is 1.41, okay, 4 points, let's write it down. So 1.4142, and it keeps on going. It doesn't repeat and it doesn't terminate, okay? So this number is irrational also because it's non-repeating and non-terminating. Any number that's non-repeating and non-terminating in its decimal form is an irrational number. Okay, this is a non-repeating and non-terminating decimal, root 2, okay? So that's irrational. Okay, now that we're done with our classification, let's go ahead and find the sum of these two numbers, okay? So what is 4.2 plus root 2? This is approximately 4.2 plus 1.4142 repeating. I'm sorry, non-terminating. Okay, gotta be careful there. This decimal points, this does here mean that the numbers continue forever. So if we add these two together, our answer is approximately 4 plus 1 is 5. 2 plus 4 is 6. 1, 4, 2, non-terminating, non-repeating. So take a look at our answer. Since our answer is non-terminating and non-repeating, what is it? It is irrational. Okay? So our result is irrational since 5.6142 is non-terminating and non-repeating. So was Patrick correct? Absolutely. So let's write that there. Hence, Patrick is correct. Okay, so let's pause for a second and go back to what we noted. Remember, we stated earlier that if you add two rational numbers, you get a rational number. Okay, but if you combine a rational and an irrational, what do you notice we got here? We combined a rational and an irrational, we ended up with an irrational number. So that's always what happens. Okay, so that's that. All right, let's take a look at problem number 26. That reads, the school newspaper surveyed the student body for an article about club membership. The table below shows the number of students in each grade level who belong to one or more clubs. If there are 180 students in 9th grade, what percentage of the 9th grade students belong to more than one club? All right, so one thing you want to note is that percentage basically means the fraction of a part to the whole multiplied by 100. Okay? The steps we're going to use to solve this problem, first of all, we're going to find the part of the whole and the whole values. We're going to divide them by one another. That gives us the fraction of the part to the whole. And then we'll multiply by 100 to convert it to percentage. Okay, we're going to be using the formula on the right here to do our calculations. For step 2, we already know the part of the whole and the whole in step 1. We just divide them and multiply by 100. Okay, all right, so let's go ahead and find our values. First of all, we want to find the part of the whole. The part of the whole is we're looking for the percentage of 9th grade students who belong to more than one club. Okay, so we have 90 students belong to one club, but we need more than one club. So more than one club is 2, 3, or more. Okay, so what we're looking at is these two combined. All right, let me do that again. We're looking at 2, 3, or more because all these numbers qualify as being more than one. All right, so let's go ahead and write it down. So for more than one club, that's going to be, we're in step 1. So we want to find the part of the whole. Part of the whole is kids with more than one club. Okay, so if you have more than one club, that means you have 2 clubs, or we're going to add students that had 3 or more. All right, so these values all qualify as being more than one. So how many students have 2 clubs? They were 33. How many students had 3 or more clubs? There are 12. Notice we are focusing only on the 9th grade column. I'm sorry, the 9th grade row. Okay, because the problem asked us just for ninth grade students, so we are focusing just on this piece right here. That's what we are focusing our attention on. Okay, so we have that down. Let's go ahead and write it. So 33 plus 12 represents the number of students that are in more than one club, and we have a total of 45. Okay, now what is a whole? What is a whole? The whole represents the total number of students. Okay, not the total number of students that are in clubs, but the total number of ninth grade students. Okay, total number of ninth grade students. Now, can you see what the total number of ninth grade students is in this problem? It's 180. Okay, so that's 180. All right, so we're done with step one. We know the part of the whole and the whole values. Step two is we're going to divide them using this formula right here. We're going to divide them and multiply by 100. Okay, so percentage, let's rewrite the formula again so we don't make mistakes, is part of the whole, that value divided by the whole, and then you multiply by 100. Okay, so let's carry out our computations here. Part of the whole is 45 divided by the whole, which is 180, and then we'll multiply that by 100. You can divide this by 1. Okay, now let's see if we can reduce this. You can cancel out the zeros. Zeros cancel out. 9 goes into 18 twice. 9 goes into 45 5 times. 2 goes in itself once. 2 goes into 10 5 times. 5 times 5 is 25. So our answer is 25%. Okay? All right, let's take a look at problem number 27. It reads, a function is shown in the table below. So we have this function right here. If included in the table, which ordered pair, -4, 1, or 1, -4, will result in a relation that is no longer a function? Explain your answer. So this relation right here is already a function. The question is, which ordered pair can we add on here that will cause this to no longer be a function? Okay, so basically we are inserting another row into this table, and we're going to be inputting either the first pair or the second pair in such a way that it causes this function to no longer be a function. Okay, it just becomes a relation. So that's the question. Which of these two candidates will cause this to no longer be a function? Okay? All right, now, one thing you want to note is that a function, a relation is a function if every input is assigned to exactly one output. If it is presented in tabular form, we want to take a close look at the x's or the inputs. There may not be any repetitions in the input. If there's any repetition, that relation is not a function. We can clearly see that this relation is a function because -4 is not repeated, -1 is not repeated, 0 is not repeated, and 3 is not repeated. So this is a function. Okay? All right. So these are the steps we're going to use for this problem. First of all, we'll go over all the x's to see if any pair would cause a repetition. We just did that. And then we will identify the pair that causes, out of these two, which pair causes a repetition in the x's. Okay, now that will be our answer. Remember, we want the relation to no longer be a function. Okay, so all we are focusing on is the x's. So we're looking at this x in the first pair and this x in the second pair. Do we have -4 here? Yeah, we do. We already have a -4 here. So if I insert the first pair, -4, 1, this relation is no longer a function. No longer a function. Why? Because we have the same input going to two different outputs. Okay, remember, a function assigns every input to exactly one output, but this input is being assigned to two different outputs, so that's why it's not a function. If we had used 1, -4, it will still be a function because there are no ones here. Okay? All right, so let's go ahead and write down our answer and then explain our reasoning, okay? So, let's see. The word is, okay, um, including -4, 1 in the table. Basically, you answer a question by, you formulate your answer by starting from the question, okay? So including -4 in the table would result, all these words I'm taking from the problem, okay, including table, -4, 1, would result in a relation, that is no longer a function. Now this is the important part. Why? It's no longer a function because the inputs, -4, will be assigned to what? Will be assigned to two different outputs. That's a no-no for functions, okay? Two different outputs. What are they? The first one is 2, and the second one is 1. Okay, remember the definition of a function. One input must go to exactly more than one, exactly one output. Okay, if one input goes to more than one output, just like this, then it's not a function. The relation is not a function. Okay, so that's why -4, 1 is our answer. All right, let's take a look at problem 28. It's reads subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. Express the result as a trinomial. Okay, so basically simplify it completely. That's what the problem is asking us to do. Okay, so first thing we're going to do here, well, something to note is that when you're adding or subtracting polynomials, only like terms, basically terms with the same degree, may be combined. Okay, you do not combine unlike terms when you're adding and subtracting. Okay, so keep that in mind. Now, these are the steps we're going to use for the problem solving process. First of all, it's important to make sure that both polynomials that you're adding are in standard form. Namely, the terms have to be in descending degree. So 2, 1, 0, 2, 1, 0. Okay, so it's already in standard form for us, so you don't get yourself mixed up. And then we're going to orient them in the right order. Okay? Order is extremely important when you are subtracting. Remember, subtraction does not commute like addition or multiplication. So if you switch the order here, you get the wrong answer. Okay? So we're subtracting this from that, so this minus that. That's the order. The second polynomial minus the first one. Okay? So right in the appropriate order, this on top, this on the bottom. And then, since we're subtracting, we just distribute in step 2 the negative sign from the subtrahend, the polynomial you're subtracting from the minuend. After distributing a negative sign to every single term, then you just combine. It becomes an addition problem. Remember, subtraction is the same thing as adding the opposite. So we're just going to add this to the opposite of that. Okay? All right, so let's go ahead and start with step number 1, just orienting the two polynomials in the right order. So we have 3x squared plus 8x minus 7. That goes on top. So this is the first polynomial we're going to write. And from this, we're going to subtract the other polynomial. Okay? So we're going to subtract 5x squared plus 2x minus 11. Okay, most students would get this reversed because, oh, since this came up first in the problem, some students might say, oh, subtract, oh, you see these two polynomials, they just put a minus here and they get it wrong. So subtracting this from that, you write it in the reverse order. Okay, so this minus that means you're subtracting this from that. Okay, so keep that in mind. Now that we have it well aligned, the squares, the first degree terms, and the constants, we have the minus here. This minus will be distributed to these three terms, and it becomes an addition problem. Okay, so let's write down the minuend polynomial expression 3x squared plus 8x minus 7. And then the subtrahend will distribute the minus to all three terms. We have negative 5x squared minus 2x plus 11. Okay, and then just add downwards. Remember, the degree does not change when you're adding, only the coefficients, okay? So if you're adding this right here, 3 minus 5, the bigger number is negative. Signs are different, so you subtract and keep the sign of the bigger. So it's negative 2. Please do not add the powers, okay? When you're adding, the degree stays the same. So negative 2x squared. And then 8 minus 2 is negative 6. Do you add the powers? No, since you're just adding. So it's negative 6x. Negative 7 plus 11. Subtract and keep the sign of the bigger. Bigger is positive. 4. So that's our answer. Negative 2x squared. Well, this is positive. You always keep the sign of the bigger. Negative 2x squared plus 6x plus 4. That's our final answer. Okay? All right, let's take a look at the last problem in this installment. It says solve the equation for x squared minus 12x equals 7 algebraically for x. All right? So one thing you want to note when solving quadratic equations is that it must be written in standard form. Ax squared plus bx plus c first. Of course, equal to 0. So you want to write it in that form first, okay? If you're trying to use the quadratic formula, if you want to factor by grouping, completing the square, it's a good practice to first of all write it in standard form, or else you get the problem wrong, okay? So steps. We're going to first of all write the problem in standard form and factor by grouping. Hopefully that works out. If it doesn't, then we have to resort to another problem. If it's factorable, we'll use the zero product property to find the values of x, okay? All right, so step 1, let's write this in standard form. How do we know that this is not yet in standard form? Well, if it is in standard form, the terms will be in descending order of degree, and it will be equal to 0. This is not 0, so we have to subtract 7 from both sides. Okay, so what do we have when we carry out that operation? We're going to have 4x squared. Can we combine these two? No, they're unlike terms. This is the first degree term with the x, and this is the 0 degree term of the constant. Minus 7 equals 0. All right, now I'm going to factor by grouping. I'm going to use the AC method. There's so many methods you can use to factor these. You can use the box method. You can use the asterisk method. You can guess and check. This is the safest method I found, so that's what I normally use. AC goes on top, B goes on the bottom. In this problem, A is 4, B is negative 12, and C is negative 7. Please keep track of your signs. Those are the big pitfalls that a lot of students fall into. Okay, AC is 4 times negative 7, which is negative 28. B is negative 12. Now you ask yourself, what two numbers multiply to give you negative 28 and add to give you 12? Okay, so let's go ahead and make a list of products of numbers that yield 28. Okay, so we have 28 here. We'll deal with the signs later. 1 and 28, this yields 29 or 27, nothing close to 12. 2 times 14. Oh, wow, this is nice. Because if I subtract these two, I'll get 12. Perfect. The answer came out rather quickly. So 2 and 14. Now let's see if we can resolve the signs. If not, maybe another pair would work. Since the sum is negative, that means the bigger has to be negative because you always keep the sign of the bigger. All right, and then when you multiply these two, you have a negative number. That means the signs must be different. So that's all we have. So we take these two and put them in here. So we have 4x squared, 4x squared plus 2x minus 14x minus 7 equals 0. We haven't changed the problem. We just expressed it in such a way that we can factor by grouping, okay? So divvy down the center with your partition in front of the sign of the third term. Now we're going to start pulling out greatest common factors, okay? So what is the GCF of these first two terms? We can factor out 2x. So let's factor that out. So we have 2x, and we're left with 2x plus 1. Remember, when you're factoring out, it's as though you're dividing. So it's like I'm dividing this by 2x and dividing by 2x. So I got this, okay? And then here, factor out a minus. Anytime you factor out a minus, the signs change. And oh, 7 is a GCF here. Negative 7 can come out. So if I divide negative 14x by negative 7, I'll have positive 2x. Okay, check your work. Negative 7 times 2x is negative 14. Good. Negative 7 divided by negative 7 is positive 1. Now here you freeze and check your work. Anytime you factor by grouping correctly, the quantities in the parentheses must be identical. Okay? So those are common factors. They're common on both sides. So what we're going to do is we're going to factor them out. Okay? Factor out these two identical quantities. If you factor them out, 2x plus 1, you're going to be left with 2x minus 7 as the other quantity, okay? So we're done factoring. What we're going to do next is step 2. We're going to use a zero product property to finish off the factored state of this problem. All right, so the zero product property says if you have the product of two quantities equals 0, either the first is equal to 0 or the second is equal to 0. Okay, so let's solve this. So if we solve the first one, just using basic algebraic procedures, subtract 1 from both sides. 2x equals negative 1. Divide by 2. X equals negative 1/2. That's the first answer. And the second result, we just add 7 to both sides. We have 2x equals 7. Divide both sides by 2. And our final answer is x equals 7/2. Okay? So those are the answers for this problem. X equals negative 1/2 and 7/2. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or need any support on the Algebra 1 Common Core Regents exam, feel free to post your questions in the comments section below, and we'll be glad to address it as soon as possible. More clips can be found on mathcaserve.com under test prep. Thanks again for watching, and have a wonderful day.